All right, we're going to start on page 196. And the book calls this equations of lines. And we're going to do a lot of equations of lines, but what we're aiming towards is this learning target. Use properties and theorems of parallel and perpendicular lines. You know how in the previous section, they would give us some information, they'd say, graph a line that passes through some point and is parallel to this other line. And so then we'd say, okay, I know that parallel lines have equal slopes, so I'd find the slope of what they gave me, and say, okay, now that I know the slope and a point it goes to, I can graph it. All right, we're going to do the same kind of thing, except instead of coming up with graphs, we're going to come up with equations of lines, which are called linear equations. Okay? So that's where we're heading. So if we're going to be able to use that kind of information to write linear equations, let's review just how we write linear equations. So we see here on page 196, says you may remember from algebra that an equation of a non-vertical line can be written in different but equivalent forms. Everybody's favorite form is slope-intercept, the y equals. Okay? But a very, very useful form is the point-slope form. Now, there are other ways to come up with equations of lines besides the ones I'm going to show you right here. And you may know those, and you may remember them, and you may not. But I'm just going to show you a few basic things that will always work. Okay? So, the slope-intercept form of a linear equation is y equals mx plus b. M stands for slope, lowercase m always stands for slope, and b is what's called the y-intercept. Think of the x-axis and the y-axis as number lines. So think of the y-axis as a number line. B is the number on that number line where the line crosses the y-axis. Okay? Then the point-slope form of a linear equation is y minus y1 equals m times the quantity x minus x1. M still stands for slope. But instead of having a b, instead of having a y-intercept, they give us this y1, x1 stuff. Hey, we've seen that a bunch of times already, haven't we? X1 will be the x-coordinate of the first point. Y1 will be the y-coordinate of the first point. The good news about this is there's only a first point. Okay? So x1 and y1 are the coordinates of that point. So, notice that in either form, one bit of information we must have to write the equation of the line is the slope. We've got to know the slope, no matter what. Okay? So, no matter what the directions say, sometimes the directions will say, write the equation in slope-intercept form. Sometimes they will say, write the equation in point-slope form. Regardless of the final form I'm going to put my equation in, the information I know tells me which form to start with. If they give me the slope and they give me a point, I'm going to use the point-slope form. I mean, they're named telling you what information you need to know to use them. Okay? So if I have a point and I have the slope, I'm using point-slope. If I have the y-intercept and the slope, I'm using slope-intercept. Then I'll show you how to manipulate and get from point-slope to slope-intercept. Okay? Because slope-intercept really is everybody's favorite form. All right? It's the form your calculator wants if you have a graphing calculator, and it's the form that's easiest to work with. So that's really our goal, is to get them in that form. All right, so on page, let's see, what page is this? 200. Ooh, we're all the way up to 200 already. We're flying. We're going to be on page 1,000 before you know it. All right, the directions say, when an equation, write an equation in slope-intercept form of the line having the given slope and y-intercept. And we're not going to graph the line. Okay? So for number one, we know that slope-intercept form, in fact, let me just write it here. Y equals mx plus b is our slope-intercept form of a linear equation. So we want to get our equation in that form. So we need to know. So the letter y stays in our equation. The letter x stays in our equation. But m doesn't. It gets replaced by a number. B doesn't. It gets replaced by a number. So we need to know m and b. Well, they tell us that m equals 4. And when they write out y-intercept, -3, they're telling us that b equals -3. So all we have to do is substitute those numbers in for those letters. So y remains y equals, replace m with 4, x remains x, replace b with -3. Now I could write plus -3, but what's better looking and simpler and more accepted form than saying plus -3? -3. That's it. We're done. Remember doing those? All right. Let's take a look at number 2. This time they're telling us that the slope equals 1/2 and that, that the y-intercept, b equals -1. Substitute. Y equals 1/2 x minus 1. We good? All right, go ahead and do number 3. Any questions? Okay. Now, the next set of problems say to write an equation in point-slope form of the line having the given slope that contains the given point. I'll just copy and paste. All right, so we're using this form this time. All right. Well, let me rephrase that. We're going to end in this form. Now, luckily for us, if you look at these, that's the information they've given us, isn't it? On all 3 of these problems, they give us the slope and they give us a point that's on the line. All right. Remember, it says the line having the given slope that contains the given point. You can say that it contains the given point. You can say that it passes through the given point. You can say that the given point is on the line. All those mean the same thing. So you need the slope and you need a point that's on the line. Those are the 2 things you need to use point-slope form. So for number 4, they give us m. They give us a point on the line. So I'm starting with point-slope form. Fortunately for us, I'm also ending in point-slope form. So y minus, and then y1, that's the y-coordinate of that point that's on the line. So y minus -2 equals m 5 times the quantity x minus, and then x1 is the x-coordinate of that point. It's got to be of the same point that we used the y-coordinate of. So x minus 3. Now, as far as I'm concerned, we have our equation in point-slope form. Okay? But doesn't it bug you just a little bit to have that minus negative? It should. You're used to simplifying things. So a preferred version of this answer would be y plus 2 equals 5 times the quantity x minus 3. Oh, come on. It's not going to let me do it. I'll leave it there. All right, well, okay with number 4? Number 5. We have the slope. It's 1/4. We have a point that's on our line, -2, -3. So, y minus, what do I put in for y1? -3 equals m times the quantity x minus -2. And that is in point slope form. It's just not in the simplified version of point slope form. So the simplified version would be y plus 3 equals 1/4 times the quantity x plus 2. And now we have it in the simplified version of point slope form. Any questions? All right, do 6. Did you get the same thing I got? Okay. All right. Number 7. Write an equation of the line through each pair of points in slope-intercept form. All right, so now we got to put our answer back to slope-intercept form. That's the y equals mx plus b. And they're not giving us the m and the b, are they? All right, we got to have the m. No matter which form we're going to use, we must know the slope. So whenever they do not tell you the slope, the very first thing you do is find the slope. Okay? So for number 7, m equals y2, that'll be 4, minus y1, that'll be -1, divided by x2, 4 minus x1, 0. So the slope equals 5/4. So now we know the slope of the line. We need to know either the y-intercept or a point on the line. Well, I do know a point on the line. In fact, I know 2 points on the line. Now, some of you may see an easier way than what I'm getting ready to do. And if you do, hang on. Okay? But so what I'm going to do is this. I'm going to say, okay, I can use the point slope form. Now, I have to end up here. But I'm good at algebra, so I don't mind doing a little algebra once I get the equation. Okay? So I'm going to use point slope form to get my equation. Then I'll put it in the form they want it in. Okay? So I'm going to ignore that point, and I'm going to use the other one with point slope form, because I've got everything I need to use point slope form. So I can do y minus, then what would I put in for y1? -1 equals m. What do I put in for m? 5/4 times x minus 0. All right, then I don't like the minus negative, so y plus 1 equals 5/4. Then in the parentheses, x minus 0 is x. I'm not quite in slope-intercept form yet, am I? But the only thing preventing me from being in slope-intercept form is that I don't have it solved for y, right? It's y equals mx plus b. I don't have y equals. Well, subtract 1 from both sides. Now I have y equals. And then to write it so that it looks like mx plus b, mx, then I don't want to write plus -1. So the -1 will count as my plus b. All right, now, what some of you may have noticed is that this point right here told me the y-intercept, because if I've got the point 0, -1 on the line, doesn't that have to be where the line crosses the y-axis, considering that that point is on the y-axis? All right, so I could have just said, okay, so y equals mx, so -1 must be the b, and there you go. Okay? And there's even another, and I didn't do it that way because, look, that doesn't happen in the other problems. So don't count on that happening. And there's another way where you use well, I don't want to show you another way. Okay, I just want to stick with one. If you remember another way and you're good at it and you can get the slope intercept form when you're done, then fine, you do it that way. I don't have any problem with that. This is the way I'm going to do it just because this is geometry. I don't want to spend 2 weeks on the algebra. Okay? All right, we good with 7? Let's try 8. All right, so we need the slope. So m equals y2 minus y1 over x2 minus x1. That'll give me a -9 over a -3, which reduces to be a +3. So I've got the slope. And then which point do you want to use? Because it doesn't matter. We will get the exact same final answer no matter which point we use. Which one do you want to use? The 4, 3 or the 1, -6? 4, 3. We'll ignore that one. We'll use that one. So y minus y1 then is 3 equals m 3 times the quantity x minus, and then x1 has to be 4. Okay? So we've got an equation. It's just not in the correct form. The way to get it in the correct form is to simplify everything and then solve it for y. So we'll simplify the right side. And by simplify, in this case, it means use the distributive property. 3 times x is 3x. 3 times -4 is -12. The only thing keeping this from being in the slope-intercept form of y equals mx plus b is the -3 is on the wrong side. So add 3 to both sides. When I add 3 to both sides, what's -12 plus 3? And now I have it in slope-intercept form. So my way of thinking is this. I always need the slope. If they don't tell me the slope, I'm going to find the slope. Once I know the slope, then I'm going to use whatever information I'm given. If I have the slope and the y-intercept, boom, slope-intercept form. If I have the slope and a point, then I'm going to start with point-slope form, then do some algebra to turn it into the form they want. All right? Let's try number 9 together. All right, y'all go ahead. Find the slope. Anybody get the slope I got? All right. Which point do you want to use? 6, 5 or negative 1, negative 4? All right, 6, 5. I would have chosen negative 1, negative 4 because I don't mind negatives. But that's okay. 6, it doesn't matter. I don't even know why I said that. It doesn't matter. 6, 5. We're using 6, 5. So y minus 5 equals m 9/7 times x minus 6. So we've got an equation. It's not in the form that our final answer is supposed to be in, but we've got a linear equation. All right, we simplify, then we solve it for y. So on the right side, we got to use the distributive property. So 9/7 times x is 9/7 x. 9/7 times a negative 6, well, positive times negative, it'll be negative. And then look, don't panic. You know how to multiply a fraction times a whole number. Make it a 6/1, right? Now, if I have a common factor I can divide out from the numerator and the denominator, then go ahead and do it. I don't, so I'll multiply straight across. Multiply the numerators together, 9 times 6, 54, then multiply the denominators together, 7 times 1, 7. So we're still good, aren't we? All right, now it's this next step that's the hard one, okay? Because I need to add 5 to both sides. When I add 5 to the left, I get y. When I add 5 to the right, I still have the 9/7 x. So what I've got to do next, I guess I'll go ahead and write this down. But what I got to do is I need to add the negative 54/7 and the 5. Okay? And I said this is the hard step. It's not that it's hard, it's that you haven't had to add fractions for a while. Okay? If we're going to add fractions, we need a common denominator. So I've got a negative 54/7 plus, and then I need to write that 5 with a denominator of 7. How do I turn a 5 into something over 7? Multiply by 7/7, don't I? Multiply 5/1 times 7/7. Because 7/7 is 1, multiplying by 1 does not change the value of the number. So when I multiply the 5 times 7/7, what do I get? I get 35/7. Well, you can't tell that that's what I get. That's what I get. 35/7. All right. Now, that means I'm going to have y equals 9/7 x. All right. A negative 54/7 plus 35/7. Combine the numerators over your common denominator. Now, a negative 54 plus 35, I'm going to get negative, right? Well, negative what? I heard 89, I heard 19. Yeah, the signs are different, so actually it's a subtraction problem, isn't it? 54 minus 35, and we get 19. All right, I'm probably going to regret showing you this. But if you have a graphing calculator or perhaps a graphing calculator app, will do the same thing. If you do, let's see, parentheses, negative 54 divided by 7, close the parentheses, plus parentheses, 35 divided by 7, close the parentheses. Choose from the math menu, choose fraction. Now everybody wants to tell mom and dad, I need $100 for a calculator, but don't. But hey, if you got that and you want to use it, fine with me. All right, are there any questions so far? Does some or maybe even most of this ring a bell? Okay, good, good. All right. Now, vertical lines are the exception to anything we talk about with lines. So the y equals mx plus b, or the y minus y1 equals m times x minus x1, neither of those apply to vertical lines. And in fact, they do apply to horizontal lines, but it's kind of difficult to see. So the easiest thing to do is to just memorize what the equation of a vertical line looks like. In fact, you have to do that because the other two forms won't work for vertical lines. And even for horizontal lines, just memorize what the equation is going to look like, and it turns out to be a lot easier. And it's this. The equation of a horizontal line is always y equals b, whatever the y-intercept is. Because think about it. What's the slope of a horizontal line? 0. So if I had y equals 0x plus b, doesn't it always just turn into that then because 0 times x is 0? So just remember that your horizontal line equation is going to be y equals b. Y equals whatever the y-intercept is. Like that one. Okay? Now, vertical line works in a similar fashion in that it's just something equals something, but there's no y at all in a vertical line equation. All right? With a horizontal line, it was y equals the y-intercept. With a vertical line, it's x equals the x-intercept. Because look at the one I highlighted in green. All the y's are on there somewhere, aren't they? All right? But only one x is on there. -2 in this case. It's the only x that's on there. So you don't need any y's to describe the ordered pairs that make the points that make up the line. All you need to know is that all the x's equal -2. So for a vertical line, the equation is x equals a, where a is the x-intercept. X equals the x-intercept. X-intercept is for the x-axis what y-intercept is for the y-axis. The x-intercept is where it crosses the x-axis. So vertical lines are always x equals a number, and that number is the x-intercept. That number is also the x-coordinate of every single point on that line. Okay? So if we see this vertical line, what's its equation? X equals 2. What's the equation of this vertical line? X equals a half, however you want to write a half. What's the equation of this horizontal line? Y equals 1. Okay? So vertical lines are always an exception, and horizontal lines are actually easier to work with if you think of them as an exception as well. Y equals whatever the y-intercept is. Now, all of this so that we can use this information to write equations of lines. Okay? So, the same information that we were using back in section 3, that the slopes of parallel lines are equal, or the same meaning is parallel lines have the same slope. The slopes of perpendicular lines are opposite reciprocals. Vertical lines are parallel to other vertical lines. Vertical lines are perpendicular to horizontal lines. We're going to use that information to write equations. We used that information in the previous section to graph. Now we use that information to write equations. Number 10 on page 200. Write an equation in slope-intercept form for a line contained in the point 3, 2 that is perpendicular to the line with the equation y equals -2x plus 6. All right. Pick out there's a lot of important stuff in this sentence. Our final answer is going to be in slope-intercept form. Okay? The line that we're writing an equation of contains this point, and it's perpendicular to this line. Remember that no matter what form my final answer is in, to write an equation of a line, I must know the slope of the line. So let's start there, so we always know where to start. That's the key. We can make this part easy, can't we? Perpendicular lines have slopes that are opposite reciprocals. The slope of this line is -2. So the slope of our line is the opposite reciprocal of that, which is, and now we're in business, aren't we? We know the slope of our line. We know a point on our line. So let's use the point slope form. So y minus y1 is 2 equals m. We now know m is 1/2 times the quantity x minus x1, 3. So what seems at first to be a really daunting task, we got an equation already. I mean, that was faster than 7, 8, and 9. Okay? You're with me on getting the equation. Now we got to put it in the form they want it in. They want it in slope-intercept form. Okay, so simplify the right by distributing the 1/2. That'd be 1/2 x. What's 1/2 times -3? And let's not write -1.5. Let's leave these as fractions. I should have said that already. Let's leave fractions as fractions. -3/2, right? 1/2 times 3, 3/2. So -3/2. Now, we need to add 2 to both sides. So that'd be y equals 1/2 x minus 3/2 plus, hey, you know what? I can save a step and save some little writing off to the side. If I write 2 in a special way, instead of writing 2 as 2, if I write it as 4/2, I'm almost finished with this problem, aren't I? So y equals 1/2 x. So what's -3/2 plus 4/2? All right, I've lost you. Let's try again. Let's not do that. That was silly. Why did I do that? All right, plus 2, right? So I need to concentrate on this right here. To add fractions, I need a common denominator. So I've got -3/2 plus, so I need to turn that 2 into something that has a denominator of 2. So if I've got the number 2, what can I multiply it by to turn it into something with a denominator of 2? What's its denominator right now? 1, right? So if I multiply by 2 over 2, I end up with 4 over 2, and now I'm in business. So now, to simplify that, and let's see, so let's -3/2 plus 4 over 2. All right, so to add those together, combine your numerators over your common denominator. So that's a -3 plus 4 over 2, right? What's -3 plus 4? 1. So I get 1/2. So y equals 1/2 x plus 1/2. Is that a better explanation of what's going on there with the fractions? Okay. Let's try number 11. Write an equation in slope-intercept form for a line containing -1, 5. So we know a point on our line. We know that we got to have it in slope-intercept form. That is parallel. Awesome, because parallel lines have equal slopes. Parallel to the line with the equation y equals 4x minus 5. What's the slope of y equals 4x minus 5? 4. So what's the slope of our line if our line's parallel to it? 4. So m equals 4. You following me? All right, so we've got the slope. We have a point, y minus what? 5 equals what? 4 times the quantity, x minus -1. And you're going to learn to love it when your slope is an integer because you don't have fractions to deal with. Simplify first, then we'll solve. So inside the parentheses, make that x plus 1. I'm still not through simplifying. distribute the 4, and now add 5 to both sides. Is that what you get? Hip, hip. Oh, that was lame. Hip, hip. That's better. Some of you said weird things besides hooray, but that was better. All right. Any questions? All right, on page 200, do 1 through 11, which we've done, 13 through 35 odd, 37 through 40, 46 through 52, 58, 60 through 63, 70 through 73. Can I hear a woo-hoo? Yeah, grumble, grumble, grumble.